Imagine a planet that behaves unlike any other. It emits more energy than it receives from the sun. It generates radio signals that can be detected from Earth. And its magnetic field is so vast, it could swallow several suns. That planet is Jupiter. But here's the strange question some astronomers quietly ask. What if some of those signals are not just natural noise? What if the largest planet in our solar system is not only a gas giant, but also a gigantic cosmic transmitter? To understand Jupiter's strange signals, we first need to understand one thing. Jupiter is hotter than it should be. Like all planets, Jupiter receives energy from the sun. But measurements reveal a surprising fact. It emits about 1.6 times more energy than it absorbs. In other words, the planet generates its own heat. Part of that energy comes from gravitational contraction. The enormous mass of the planet slowly compresses under its own gravity, releasing heat. Another source is residual heat from its formation, left over from the birth of the solar system. There may also be a process known as helium rain, where helium condenses deep inside Jupiter and sinks downward, releasing additional energy. Together, these processes turn Jupiter into a massive internal heat engine. But heat is only part of the story. Jupiter's internal energy leads to another phenomenon, one that we can actually hear. Jupiter has the most powerful magnetosphere of any planet in the solar system. It is so vast that its tail can stretch hundreds of millions of kilometers. When charged particles interact with this magnetic field, they produce intense radio emissions. But in recent years, observations of Jupiter have revealed another strange detail. Some of this planet's radio bursts behave a little too orderly. And that is exactly what has led some researchers to ask an unexpected question. What if we are not hearing just noise? Since its arrival in Jupiter's system in 2016, the spacecraft Juno has been recording enormous amounts of radio data. Most of these signals can be explained by interactions between Jupiter's magnetic field, plasma, and the moon Io. But within the extended mission data, scientists began noticing bursts that appear unusual. Some decametric radio bursts arrive not randomly, but in groups, with intervals that seem suspiciously regular. A few researchers have suggested that these intervals sometimes resemble mathematical sequences. For example, patterns that appear similar to the Fibonacci sequence. For now, this remains only a hypothesis and a topic of discussion. But it raises a very strange question. A chaotic gas giant made of storms and plasma. Why would it sometimes produce signals that appear mathematically structured? If this is a natural process, we may simply not understand it yet. But if someone wanted to hide a signal inside cosmic noise, Jupiter would be the perfect place. If someone really wanted to hide a transmitter somewhere in the solar system, they probably wouldn't choose a small planet like Earth. They would choose the noisiest radio source in the entire system, Jupiter. And there is another detail. One of the most fascinating properties of Jupiter's radio emissions was discovered as early as the mid-20th century. At certain moments, the planet produces radio bursts so powerful that they can dominate the natural radio background of space. These signals are known as decametric radio emissions, often called DAM bursts. The most intriguing part is that many of them are linked to the motion of one of Jupiter's moons, Io. Io is the most volcanically active world in the solar system. Its eruptions release enormous clouds of ionized gas into space. When this plasma interacts with Jupiter's enormous magnetic field, it forms a gigantic magnetic connection between the moon and the planet, often described as a plasma flux tube. In effect, Io acts like an electrical generator, moving through Jupiter's magnetic field. This interaction can produce electric currents reaching millions of amperes. Those currents can trigger powerful radio emissions. Some of these bursts are so strong that they can be detected with simple radio antennas on Earth. When converted into sound, they resemble crackling, whistling, or short pulses that almost sound like digital transmissions. On radio spectrograms, these bursts appear as bright arcs and streaks, as if signals were being drawn across the screen. During such events, Jupiter becomes one of the brightest radio sources in the sky. In other words, the largest planet in our solar system sometimes behaves like a gigantic natural radio transmitter. And every time Io passes through certain regions of Jupiter's magnetosphere, this cosmic transmitter can switch on again. Science offers natural explanations for Jupiter's signals. But if some of Jupiter's radio signals really do show unusual patterns, an even more surprising question emerges. What if we are not just observing a natural phenomenon, but a signal amplified by the planet itself? Jupiter is the largest planet in the solar system. Its magnetosphere is the most powerful planetary magnetic field we know. It is so vast that it could swallow several suns. And this is exactly what makes Jupiter an intriguing candidate for an unusual idea. Some researchers and futurists have asked a curious question. What if the interior of a gas giant could act as a natural signal amplifier? Imagine a transmitter hidden deep inside the planet. It wouldn't even need to be extremely powerful. As the signal travels through Jupiter's immense magnetosphere, it could be amplified by the surrounding plasma and magnetic currents. In that sense, the entire planet could function as a gigantic antenna. But that leads to another question. Why would anyone choose Jupiter for such a device? The answer may be surprisingly simple. A gas giant is almost the perfect hiding place. Its atmosphere consists of thousands of kilometers of clouds and violent storms. Any structure hidden deep within it would be nearly impossible to observe directly. Even more importantly, the planet contains enormous energy. Its internal heat, magnetic field, and plasma flows could power a system for thousands or even millions of years. If a civilization wanted to leave a long-lasting signal somewhere in a planetary system, a gas giant would be one of the best possible locations for such a beacon. Ideas like this often appear in science fiction, but the idea raises an intriguing question. Where exactly is the boundary between natural phenomena and engineering we simply do not yet recognize? But if we imagine for a moment that Jupiter could actually function as a cosmic radio beacon, another, even stranger question appears. Who is the signal meant for? Is it being sent into the depths of the galaxy? Or to someone who is already here. And if something more than storms exists within Jupiter's atmosphere, we may have been looking straight at it for decades. For centuries, a gigantic storm has raged in Jupiter's atmosphere, the Great Red Spot. Officially, it is simply an enormous and long-lasting atmospheric vortex. But some alternative interpretations have occasionally appeared. What if the storm is actually a form of camouflage? The one I talked about in a previous video. There is one fact about Jupiter's Great Red Spot that rarely gets discussed outside scientific circles. This gigantic storm has existed for at least 350 years. Astronomers have been observing it since the first telescopic records of the 17th century. But that's not the strangest part. According to data from the Juno spacecraft, the Great Red Spot extends about 300 to 500 kilometers deep beneath Jupiter's upper cloud layers. For comparison, the most powerful hurricanes on Earth reach depths of only 10 to 15 kilometers. Which means this is not just an atmospheric storm. It is a massive vertical structure reaching deep into the planet's atmosphere. And the real mystery is that after centuries of observation, scientists still cannot fully explain why the storm has not dissipated. It changes. It slowly shrinks. But it doesn't disappear. Which implies that somewhere deep within it, there must be a persistent energy source sustaining the structure. And if someone ever wanted to hide something enormous inside the atmosphere of a gas giant, a storm the size of planet Earth would be the perfect camouflage. But if the Great Red Spot is not just a storm, what exactly is inside it? What if something much larger is hidden beneath it? Perhaps an ancient observation station with the artificial intelligence beacon. Sure, mainstream science calls it just a hypothesis. But here's the thing. After Juno finished its job, they deliberately directed it straight into Jupiter's interior and conveniently switched off the cameras. Coincidence? But if humanity ever dares to send probes straight deep into Jupiter's atmosphere, we may learn far more than we're prepared for. So, Jupiter remains one of the most mysterious worlds in the solar system. It emits more energy than it receives. It sends powerful radio signals into space. And deep inside its atmosphere, processes may be occurring that we still do not fully understand. But one question remains. When we listen to Jupiter's radio emissions, are we hearing only the noise of nature, or perhaps a very old cosmic beacon transmitting for billions of years?